right, this morning we are going to work on finding area and perimeter of irregular figures. And so just have your note packet and we're going to get started. So perimeter, if you guys remember, is add up all the sides around the outside. So I don't have all of these labeled, so I've got to find some missing sides here and see if we can label those. So I'm just going to walk through how I would do that. Now, if I go horizontally across this figure, there's a little disconnect there, but those two segments are both 4, and those two segments, if I did segment addition, if they matched up, if I add those together, that should give me the length of the entire side across the bottom. So this side, I'm just going to say 4 plus 4 should be 8. Okay, the other side I'm missing is right here. All right, and so I'm going to look at my vertical distance. So this is 4. This I don't know. But those two segments added together would go all the way up the figure and match up with this vertical side, which is 7. So this segment here plus this segment here has to add up to 7. So if this is 4, then this piece would have to be 3. And then all we have to do to find the perimeter is add those guys. All right, so added all the sides, went around the figure, added that up, I get 30, and that's going to be units since I don't have any kind of a label here on the diagram. Okay, that's your perimeter. Now, your area, there's a couple different ways that you could do this, so if you don't do it the way I'm doing it, that doesn't mean it's wrong, but we should get the same answer. What we want to do is break the figure into figures that we do know how to find the area of. So, it's totally up to you. I'm just going to draw like a little bitty line right here. And what I'm going to do is I'm going to find the area of this little rectangle right here, which is just going to be 3 by 4, base times height, length times width, however you want to think about it. So the area of that part would be 12. And then I'm going to find the area of this other rectangle, which would be right in here. And this, the one side is 4, the other side is 8, so length times width, base times height, 4 times 8 is 32. Okay, now this is important. When you're doing this, don't multiply these numbers. That's the biggest mistake people are going to make. So for the area there, I'm going to take the area of this rectangle, which is 12, plus the area of this other rectangle, the way I cut that up, add them together, and that'll give you the total area of the figure, which would be 44. And then this is going to be units squared for area. All right, different figure. Pause this at any time if it's going too fast, and you can rewind and go back if you need to. All right, so for perimeter here, I have 3 of the sides labeled. What I don't have labeled is this side here. Okay, now, what I do have, though, is this dotted line. I do have a right triangle, so I just want to kind of highlight what I'm going to do here real quick. If this is 18, and this is a rectangle here, this much of it would also be 18. Okay, if that's the case, if this whole thing is 28, this much would be 18. This piece right here just in the triangle would be 10. Okay, now the other piece of that triangle, this dotted line, that is just the other side of this rectangle. So this distance is going to have to match up with the distance across the bottom, which is 24. Now, what I'm going to do here is use the Pythagorean Theorem because I've got 2 legs in a right triangle, and that'll allow us to find the third side. So I'm going to just pause it and set that up. You can see I went through, did my Pythagorean Theorem, it's 24 squared plus 10 squared, and I labeled that side we didn't know C, like the Pythagorean Theorem, a squared b squared equals c squared. You end up with 26. Okay, and then I just want to caution you here really quickly. When I go through and label other numbers in the diagram, sometimes people will not find the perimeter correctly because they will put in other numbers that are in the diagram. So just be really careful that as you go through, when you do the perimeter, just add up the sides around the outside of the figure. Okay, so when I do that here, this is 26, this is 18, this is 24, and this is 28, and those are the 4 numbers I'm going to add together to get my perimeter. So when we add those up, we should get, as you can see, I wrote it down here, 26, 18, 24, 28 is going to give me 96 as a perimeter. Okay, now, just like the last one, I would find the area kind of separately here. So I'm actually just going to kind of draw this to the side so I can rewrite on this so it's not so confusing. The right triangle there, if I want to find the area of that right triangle, I can just do that real quick. Remember, area of a triangle is base times height divided by 2. And I can see the base and the height right there in the problem. So I would just do 24 times 10 divided by 2, which is going to give me 120. And this would be centimeters squared. Okay, and then the area of the rectangle, 18 by 24. Now, area of a rectangle is just base times height. We don't do the divided by 2 part. So I'm just going to do for that 24 times 18. And then what we'll do is we'll add these results together. This is 432. Okay, so that's the triangle part. That's the rectangle part. We're going to add those together. So I'm going to do 432 plus 120 to get the total area of the figure, 552, and this is centimeters squared. Okay, we have one last figure to find perimeter and area, so I'm going to go through some symbols with you. We talked about this a little bit, that if you have these little markings, those indicate that those sides are all congruent. So if this one's 11, that means this one is also 11. That means this one is also 11. And then when you see different markings, just to go over this side has 2 little slashes on it, and so does this. So this is indicating these 2 sides are the same, but they are different than the ones with the single marks. So all the single marks are the same, all the double marks are the same. So this will be 15, even though that's not labeled there. And then we have a triple mark here, so those 2 segments, I'm just going to grab my highlighter here real quick. This segment and this segment are going to be the same. We're going to have to figure those out to be matching here, because this one is 9, so that means this one is also 9 millimeters. Okay, and then the only side that we don't have labeled in that figure if we're trying to do the perimeter is this whole side across here. Okay, now here's how I would tell you to figure that out. That's horizontal. Up here across the top, this is horizontal. This segment, if these matched up, this would connect. And if these matched up, kind of the same thing. So 11, 11, 11. So I'm just going to add those together. That's going to make this side across the bottom be 33. And then what we're going to do is we're going to go around the outside and add each of the sides and get the perimeter. So I'm going to pause it and write it down. Be real careful when you do this, you don't double count any of the sides. So I just started right here. I went 15, 11, 9, 11, 9, 11, 15, 33. I added all those up, and you should get, as the perimeter here, 114 just millimeters. Okay, now I'm going to switch over to do area. Again, there's multiple ways that you can do these problems, but you want to split the figure into figures you know how to find the area of. So I don't have a formula for this figure here, but I do know how to find the area of a rectangle. So it's up to you how you want to cut this up. Just as an example, I'll give you what I did. I cut like a little line right here and a little line right here, and maybe I should come over to the side here and kind of redraw this so it doesn't have so many markings on it, and maybe we can see this a little bit better. Okay, so I've got a rectangle here. This is 15 by 11. This rectangle over here is also identical, so it'd be 15 by 11. So I can find both of those areas right away. I would just multiply base times height, 15 times 11. This is going to give you 165. Same thing here, base times height, 165. Now, I still need to find the area of this little piece right here. I know this is 11. What I have to figure out is what this little dotted line would be. Okay, so let me just grab my highlighter here. This is 15. And if you guys look back to the diagram here, this much of it is 9. So if this much of it is 9, 9 plus this little dotted segment I put in here has to add up to the 15. So that is going to force this little dotted line I have to be 6. Okay, and then once I have that, I know the other side of that rectangle is 11. We'll just do 11 times 6, which is 66. And then I have these 3 different areas that make up the whole figure. So all we're going to do is add these guys up, and that'll give us the area. All right, so when you do that, you should get 396, and these did have labels, so this is going to be millimeters squared or square millimeter. Okay, for my next example, forgive me, the copy didn't look really great when I looked at it when I flipped the page, so I kind of shaded this a little bit more heavily, but the area here that I have in my green highlighter is supposed to be shaded, and it says there in the directions, find the area of the shaded region. So what I would tell you to do if you got something like this, I would find the area of the whole thing, like pretend this was filled in too. Right here, pretend that was filled in. This would just be a rectangle. It's just going to be base times height or length times width, which is 8 times 12. Okay, so if I do that, the whole thing, like if I pretend there's no little bitty hole there, 8 by 12, this would be 96 inches squared here in this case. Now, the part that is cut out here, this little base square here, is 4 by 4. All those sides would be the same. So this would be 16 inches squared for the area of that part that's not shaded. So if I want just the shaded part, what we can do, just take the area of the whole thing, the 96, and then I'm going to subtract out that little square in the middle that's not shaded. So I found the area of each of those. And then my leftover is going to be the area of the shaded region, which is 80. Okay, kind of the same thing. This one you can see the shading a little bit better on the copy. I would find the area of that whole rectangle, which is 8 by 13. And so if I multiply 8 by 13, we're going to get 104. This would be meters squared. And then what I want to do is subtract that part that is not shaded, which is this triangle here, which I'm just kind of recreating to the side. Okay, now I can see the height of the triangle is 6, right, in the diagram. The base of the triangle you have to kind of figure out because it's not labeled. So this whole side is 13. And that would match up with the whole side across the bottom. So this is 4, this is 4, so those are both 4. So that would give me a total of 8. What I want to do is take 13 minus those 2 segments. So 13 minus 8 would leave me with that base being 5. Now, whenever you do area of a triangle, it's going to be base times height, and then don't forget to divide it by 2 or multiply it by a half. So this would end up being 5 times 6 divided by 2. That's 30 divided by 2, which is 15. Okay, so then what I would want to do, that's my area there, I would want to take the area of that entire rectangle, which is that 104, and we get to subtract the triangle, which is the 15. And so then the leftover should end up being 89 meters squared. Okay, for the last question, we're going to find area and perimeter in the coordinate plane. I'm going to pause and graph this, so you do that too. Okay, so for the coordinate plane, hopefully your graph looks like mine. Any vertical or horizontal line, we can just count boxes for the segment if we're trying to find the perimeter. So from A to B, this is going to be 8. From B to C is going to be 11 across the bottom here. D to C, we're going to have to figure that out in a second because that's a diagonal line. And then from A to D, what I have there is going to be 5. Now, there's different ways you could do this. Here's how I would find from D to C. I'm going to try to make that the hypotenuse of a right triangle so I can use the Pythagorean Theorem. So I'm just going to drop a vertical line from D to the opposite side. These I'm going to use as my 2 legs for my right triangle. Okay. Now, as I do that, these numbers I do not want to use when I find my perimeter, but this will also help us maybe do our area. So from here to here, from D to where it touches the base of the figure is going to match up. So this is going to be 8. This is right at 0 on the y-axis. And then I'm going to go over to 6. I'm sorry, 0 for x. 0 for x over to 6. This will be 6. So for DC there, I'm going to do 8 squared plus 6 squared. That's going to be that side squared. So that's the hypotenuse. This is going to end up being 64 plus 36. And that's going to be equal to the hypotenuse squared. So we'll have to take a square root here. That's 100. And then this ends up being a nice number. So that segment from D to C is 10. Okay, so for my perimeter, I'm just going to add up, and be careful here. Don't use these numbers we put into the figure. We want to go around the outside only. Okay, so I highlighted that. Here's my perimeter. 5, then 8, then 11, then 10, just around the outside of the figure. If you add those up, you should get 34 units, since we're on the coordinate plane there and we don't have a label. And then for your area, what I would do is find the area of the rectangle here. This is just going to be 8 by 5, so this will be 40. And then the area of the triangle, I'll try to draw this separate so you guys can see it. This is 8 by 5, so this was 40 units. And then for the triangle part, we've got the base and the height right in the diagram from where I dropped those lines there. Just don't forget for area, it's base times height, and then you got to cut it in half. So this would be 6 times 8 divided by 2, which is going to end up being 24. To get the area of the total figure, we add these together. So the rectangle plus the triangle, and we get 64. For area, we're going to write down units squared.